This is chapter 9, problem 78. A thin light wire is wrapped around the rim of a wheel. The wheel rotates about a stationary horizontal axle that passes through the center of the wheel. The wheel has a radius of 0.18 meters and moment of inertia for rotation about the axle of I equals 0.48 kilograms meters squared. A small block with mass 0.34 kilograms is suspended from the free end of the wire. When the system is released from rest, the block descends with constant acceleration. The bearings in the wheel, the axle are rusty, so friction there does minus 9 joules of work as the block descends 3 meters. What is the magnitude of the angular velocity of the wheel after the block has descended 3 meters? So for this problem, we use that our kinetic energy is equal K is equal to 1/2 mass velocity squared plus 1/2 inertia times angular acceleration times angular velocity squared. So using conservation of energy, we use kinetic energy plus potential energy plus friction is equal to kinetic energy plus potential energy. So our kinetic energy to begin with, initial kinetic energy is 0, but our potential energy is mass times gravity times diameter of the wheel, basically. So plus the friction, which is equal to our kinetic energy and potential energy, which is equal to our kinetic energy because our potential energy is 0 at the end of this. So we get that 1/2 mass velocity squared plus 1/2 inertia angular velocity squared. And we know that our velocity is equal to the radius times angular acceleration, or velocity, radius times angular velocity. So we're able to have mass times gravity times height of the wheel, or diameter, plus friction is equal to 1/2 mass r angular velocity squared plus 1/2 inertia angular velocity squared. So now we just solve for our angular velocity, which gives us the square root of 2 times mass times gravity times diameter plus friction over inertia plus mass times radius squared. And then we can plug in the numbers which were given to us in the equation. For mass is 0.34 kilograms, gravity is 9.81 meters per second squared. Our diameter is 3 meters. Not diameter, it's the height of the wheel, so where the wheel is at. So 3 meters plus -9 for friction over our inertia is 0.48 plus 0, mass again is 0.34, and our radius is 0.18. So when we solve for this, it comes out pretty straightforward. Our angular velocity is 2.01 radians per second.